Okay, so we are going to introduce this new quantity. We're going to invent, as physicists, we're going to invent this quantity called momentum. And because we've already used up m for mass, we're going to go with the next obvious letter for momentum. We're going to use p. That makes a lot of sense.
What? How why, sir?
Yes.
Not like O.
And so momentum is just the product of mass and velocity. So it's like a quantity, a made-up quantity, not something that really exists, but we find it useful to calculate. Mass times velocity. Mass measured in kgs, and velocity measured in... So come on, if you're sharp, how much is momentum measured in?
Meters a second.
Nice. kg ms minus 1. You just join the two units together and start with the one that comes first in the alphabet, right? Kgs comes before meters, so we go kg meters seconds minus 1.
Oh dear.
And so momentum of
Is
an
that
object...
actually the way it's organised that way, or is it just a way of remembering it?
Anyway, so momentum, we can kind of, if we're trying to think about what does momentum mean, it's like the oomph of an object. And so, like, if you've ever been hit by, I don't know, like a baseball or something, that's a real oomph situation. Not because a baseball's got a particularly large amount of mass, but because when it hits you, it's kind of going quite quick. And so, that's an oomph situation. Also, if you've ever stood behind a bus and then the bus went backwards and hit you, that's an oomph situation. Not because the bus is going particularly fast backwards, but because it's got a lot of mass. And so we're thinking about the oomph, kind of the momentum of an object, like how much oomph it's got. The question you should be asking though is, why do we care? Why would we go making up some new quantity when we've already got mass, we've already got velocity? What new insight are we going to get by multiplying them together? It turns out that in a collision or in an explosion, collisions and in explosions, the total momentum of all of the bodies involved stays constant. So we can analyse collisions and explosions, work out how fast different bodies must be moving before or after the collision, just by knowing that the total momentum in that action, that explosion or collision, has to stay constant. Only works, obviously, if no external forces are acting. Like if someone crashes their car into someone else but they've got the handbrake on at the same time, that's going to not let velocity stay the same. Their velocity is going to be decreasing even while they're having the collision. And so that would be an external force. Momentum's not conserved then, but the reason we say no net external force acts is if you think about a collision, when you have a collision, the two bodies come into contact with each other, and so absolutely there are forces acting. There are the contact forces of like one body smacking into another one. That's what causes like the speed to the momentum of each individual body inside the collision to change. Is the internal forces, the contact forces. So we're only worried about excluding external forces. So if there's an external force, momentum's not conserved, but if there's only internal forces like one body smacking into another, then the total momentum is conserved. Obviously, if one car's going fast, hits another car, and that other car gets projected off fast, the momentum of the first car is going to decrease, the momentum of the second car is going to increase, but the total momentum of the system, car 1 and car 2, stays the same.
So they just gift one momentum to the other?
Yeah, could have given it away. Throwing something against a wall, though, is complicated. Like, is momentum conserved when you bounce a ball off a wall? Is momentum conserved?
They come back slower.
Comes back slower? What's going faster if the ball comes back slower?
The wall?
So the wall is moving away and the wall's connected to the earth. And so, yes, you can cause a tiny change in momentum to the earth, but thing is that it's got so much mass that our tiny little change in momentum is just negligible. We don't notice it.
I have a real good idea, Sam. You know how when you like write stuff on the board, you should tell me when you're gonna write, and then I'll go like that, and then when I take my hand away, there'll be stuff written on the board, and it'll be like a cool transition, like YouTubers do.
Like real analog though, not any of this modern digital.
No, so basically, I put my hand over it, and then I cut the camera, and then you write it, and then I take my hand away, and it's there, and you're like,
No more time lapses.
yeah,
We'll try it next time.
okay.